The question that we are solving now belongs to test series 1 and it is of control system subject. In specific, it belongs to frequency domain analysis of control systems. The question is number 36. As per the question, there is a control system of open loop transfer function g of s h of s is equal to k by s into s plus 2 into s plus 4. And the system is of unity negative feedback. There are two statements given based on the open loop transfer function of the control systems. The statement 1 is gain margin of the control system is 21.58 dB for k is equal to 4. And the second statement is gain crossover frequency of the control system is 0.72 radians per second for k is equal to 6.2. We have to pick the correct option based on correctness of these two statements. Initially, say for k is equal to 4, g of s h of s is equal to k by 4 by s into s plus 2 into s plus 4. So g of j omega h of j omega is equal to minus 4j by omega into 2 plus j omega multiplied by 4 plus j omega. On rationalization, it can be simplified as minus 4j multiplied by 2 minus j omega multiplied by 4 minus j omega divided by omega into 4 plus omega square multiplied by 16 plus omega square. This can be further simplified as minus 24 divided by 4 plus omega square multiplied by 16 plus omega square minus j4 multiplied by 8 minus omega square divided by omega into omega square plus 4 multiplied by omega square plus 16. So for gain margin, we have to find the phase crossover frequency. So for phase crossover frequency, imaginary part of g of j omega multiplied by h of j omega is equal to 0. That implies omega p equal to 2 root 2 radians per second. Also, gain margin is equal to 20 log 10 mod of 1 by g of j omega p multiplied by h of j omega p. So this is equal to 21.58 dB. So that implies statement 1 is correct. Now for k is equal to 6.2, for finding the gain crossover frequency, magnitude of g of j omega g h of j omega g equal to 1. That implies 6.2 divided by omega multiplied by square root of 4 plus omega square multiplied by square root of 16 plus omega square is equal to 1. On substitution, we see that omega g equal to 0.72 radians per second is the gain crossover frequency. So the statement 2 is also correct. We see that statements 1 and 2 are correct. So that implies option A is the correct option.